table. And the table. So you got too much crap in the way, you gotta walk over everything. Race bike's gonna get put away here shortly. It's in the way. Okay, I got a nice thick heavy duty 3/8 washer. Bingo, fits in a lot better. And we stick it in for a nut over here. Barely. Barely is fine though. I'm good with barely. Put that back over there, we don't need it. There we go. Torqued. Okay. Spin the other ones down, I guess. I don't think I tightened anything yet, did I? Nope. I missed a nut on that one. Where'd the nut go? Hard to tighten a bolt down with no nut. Okay, put that already. I'm gonna zip gun back there, buddy. I think I did this already. Yep. That's this big one. Okay. That's all torqued in. Okay. Now these all three when they're real tight, so there's no really moving. There's no wiggle room on all that, like the other case had. I know these mounts are off. So you can use a little thin block, use a big thick one. Not very flat. You go like this, and it goes like twist too, like this. It goes side to side. It goes front to back. It's rolling. Mounts are very warped. They look pretty flat, but they're way the hell off. They're not flat. In the back they're close. In the front they're not. Okay, so this is why I need the other case. So I can get the idea of the offset between this side and the other side. Now this side here should have been really close, and it is really close. Knock off the burr right here. Okay, straight edge. And our feeder gauge. Oh, there's not a shim stock. So we're not hitting like our thicker one. I think it was around 3,000 what I had before, but it's been don't remember. It's been a while. Let's see. It is not 3,000. No, that's because there's two of them. There's 5,500. 2.5 is tight. 2.5 goes in partially in the stop. and our next one's 1. So we don't have a 2. But 1.5 went in there, so it must be 2. So it's got a 2/1000 step in there, which is pretty close, but it's still in there. And that was in there from the original, so when I machined the case, I had that. So it's repeating the very small difference in here. So this gives me a good surface to come off of for jigging up to, because it's all very flat. I'll make a slim cut right across here just to make sure it's dead flat, but it's really, really close. Now, once I know what the offset is from this side to this side by measuring the other case, assuming the aftermarket case is made right, which is definitely assuming a lot. But at least I can come in and I can cut this side here, because both of these have been kind of welded on a little bit, so I don't know exactly where they're at. So we're gonna make sure these are flat. If you don't make these things flat, the cases will break. You tighten down the frame and they'll break. Same thing if you don't shim the frame. If the frame's not square, which a lot of them is not, then it breaks the cases. That's why you see these ears broken off all the time. So that's why it's important to shim your motor to your frame. So usually what you do is you tighten the back of this down here, and you see what the difference is in the front. Then you shim that up, then you tighten this down, and come back and check the back and see if it stayed on top of the frame or it lifted up or did something stupid. So it's all part of doing it. Alright, so there you go. This one's pretty much ready to put in. I didn't check the arrow hole to make sure it went through. Guess we can check that right now. I'm going to use a long nozzle for that. We'll just put it in the hole and blow on it. See, that goes through on the other side over here. Yep. Fingers over the hole on the other side, so it's definitely blowing through. And this side here has nothing to line up to, because there's no hole on that side. So there you go. So that would be no hole on this side, hole on this side. So there you go, all lined up. Alright, so if I did all my machining on these cases correctly, these main bearings should be just about perfectly in line with each other. Because I came off the center line of the case when I machined everything. But we'll find out. You don't know until you put a hole through the hole. When you put a hole through the hole, you'll find out how bad things are. Alright, and then these decks here are going to have to be lightly cut. They're pretty close, but they do need to be matched. And as I recall, the bore in here is real tight, so you can't put a cylinder on it. See, it doesn't go in the hole. So the spigot's going to be cut bigger. So you got gap on the front of the cylinder back, but not on the side, because the case has been thinned up. They have been machined a little bit on both surfaces, so that's a little bit thinner than stock. Now the amount that I have to cut this out, it tells me how much I actually cut these too thin. I know it's not very much, but I can also measure it right now and I'll tell you. So if you go over here, get a measurement, 684, 694, so you take half of that, basically about 690. And measure this way here. We're at 61, so we're about 30 thou. So that means I took about 30 thou off both sides of these total, because we're 30 thou narrower here than what our average number with these two here is, because the cases are slightly skewed apart from one another. So there's 10 thou difference between here and here. There's 30 thou difference this way. So that means I cut 30. I thought a little bit closer than that. I thought it was more in the 20 area, but oh well, it's 30. It is what it is. So considering the amount of work on the case, 30 thou, that ain't much. Very minimal cutting, but it is. So that means these main bearings are going to be 30 thou tighter in there than what they would have been before they did that. But that's why they make different thrust washers. So. And these cases have been cut. Now why is this higher than this side? This surface has been cut for some reason. I don't know why this has been cut. I can see the machine marks on it. I just didn't know why it was done. Usually when you cut a deck, the deck gets lower than this. There's no reason to cut this surface. So why did this surface get cut? I do not know. I have no idea why they would have cut that. We know a distributor fits in the hole, so it doesn't have the problem this motor has. That fits in there, no problem in that. It's definitely engaged in the teeth pretty good, so that's not a problem being too high. Yeah, I don't know why that was cut. Usually that's just flat all the way across, and like I said, when you cut the deck in here, you don't cut over here, and you leave that surface, and you can tell how much these have been cut. This one's the opposite. It's weird. You can see the rough-ass finish through here too. So, I have seen rough-ass finish like the before from Harley, but it's usually pretty smooth from Harley. So, whenever you see really rough cuts like this, you always think someone's been in there dicking around. So that's why we're going to do some measurements and see the difference in angles between these two and between here and here, and see if they're all the same like they're supposed to be. 45, 45, and the same. It would be 0 to 0 when you put this all in there, but don't be surprised if there's some errors in there. Alright, that's about it for that one. So we're going to jig up off of this case over here, and then we're going to see if this one's close to what that one is. Now, I'm not necessarily going to cut to what that is, because I don't know how accurate that is. That's a piece of crap. Moto Technique thing made wrong. So I'm going to use it as a reference, but not 100% reference. But it'll give me an idea about what this should be, and I'll make a decision what I want to do. I usually like averaging numbers. That way you don't get stuff like this where it's weird looking. But alright, that's it for that for now. It's almost tomorrow. Time to go home and wake up for tomorrow. Get a fresh start today at noon. Or midnight. Alright, there you go.